Okay, sorry for the delay. We find some issue in our cluster, so maybe today I cannot show the. The plan was to was gonna show a small demo by using the Java High-Level API to build the application, but we have some issue in our cluster, so maybe today we don't have the demo. But anyways, I keep the kind of running out of time. Well, I'll keep this talk short, quick. So before I jump to the new high-level API, I would like to give you guys, maybe some of you guys are not familiar with Apex. I would like to give you guys a quick overview of Apex. So Apex is a distributed data processing engine. It's in the same area as Flink, Spark Streaming, and Storm. So Apex has some as a distributed data processing engine. Apex has some nice features like fault tolerant. Apex is fully fault tolerant, and Apex is also high scalable. Like you can scale up your application with your cluster, and also the latency is very low because we process data in event by event. Not like some engine is micro batch, so this picture gives you a view of how Apex engine runs. So if you run Apex in a distributed mode underneath the Apex engine, so this bar here is the Apex core engine, and under this bar here is the Hadoop. So Apex, the distributed mode of Apex application depends on Yarn and HDFS in Hadoop. We use Yarn as the resource manager to get resource from the cluster, and we use HDFS to HDFS is used by default for saving the state of all the operations, like intermediate state of all the jobs, to make the job fault tolerant. And on this core engine, we have a bunch of operator libraries. Those libraries include the I/O library, which talk with external system like Kafka, HDFS, NoSQL database, JDBC, so on and so forth. And also the library includes some useful algorithms, or some useful transformations like filter, and some algorithm like aggregation, something like that. So these two parts are Apex, and upon these two parts, there are data torrent UI products which can actually monitor the application and do some management and do some data visualization from the results of the Apex application. And there's a REST API vertical bar there. So basically, each layer use REST API to talk to each other. Next. So this picture gives you an idea of how Apex, the different components in Apex application, and how Apex application use Yarn to do distributed computing. So over there you see this small box called Apex CLI. It's a command line tool in Apex. Which usually when you start an Apex application, you use the command line component Apex CLI to submit all the dependencies all your application files into HDFS and talk to the resource manager of Yarn and ask for the resource it needs to run the application. And then in this example, there are 1, 2, 3, 4, 5, 6 different nodes. Before the individual node, there's a special node called Stram. Stram is is short for Streaming Application Master. So the responsibility for Stram is to coordinate all the nodes, all the other logical nodes. So there are under Stram, the Stram manage to 6 different logical nodes here, and you can see Apex is very flexible. It can deploy nodes in different location. Like it can, for example, 1 and 2 are running on different node. 3 and 5 are running on the same node, and 4 and 6 is even running in the same process here. Each node is responsible for some real data processing, and you can see the dot line that connect each node. That's actually the data like flow in between nodes. Like you can see the output of node 1 will go to the input of node 3. Right. How to make it back? Sorry. Okay, this is the current current API, current development model we have right now. So each Apex application is a DAG, directed acyclic graph. So the vertex of the graph is what we call the operator. Operator is the interface in Apex library. So each operator is a compute unit that we can distribute to different nodes to run. Each operator has a couple of input port and output port. Input port is responsible for taking data into the operator to run, to compute, to process, and the output port is responsible to push data to the next operator. So first we add the operators into the DAG, and then we connect the output port of operator to the input port of the next operator, which the connection between operators are called stream in Apex, and the data, which we call tuple, flying over the stream, and the stream is the edge of the DAG. And also here I want to mention that each operator is stateful. So the stateful means the state of the operator will be persisted into some persistent layer. So if anything goes wrong, let's say one operator goes down, Apex engine will bring up another instance to recover from the previous saved state. Yeah. Okay. Here is the current what the current application look like in Apex. Each application in Apex is called a streaming application, and you have to construct your DAG in this you have to override the popular DAG method to construct the DAG. As you can see, to construct DAG, you first add a couple of operators, which is a vertex in the DAG. In this example, this is the word count example. So in this example, it actually has 3 vertices. One is word input, and then count, then console. And after you add the operators, you connect them together. So you connect what input to count, and then you connect the count to console. What input is responsible for taking data from files, and then count is for just counting, and then the console is just output all the result to standard output. Next. So this is a current API we have right. This is API we have right now. There are some, though it's very flexible because you can add any operator you want, and you can do anything in operator, right? You can. For example, if you want to do some aggregation, you can keep the partial aggregation as a state of the operator, and you can ingest data in operator. Basically, you can do anything in operator. But the problem for this API is this API is very flexible. But the problem for this API is it's very verbose. It's not very obvious what if you look at if the DAG grows very big, it's hard to maintain. It's hard to debug. It's hard to figure out. For example, if I forget to connect two operators, you don't know where you forget to connect them, and you will get into trouble. And also, these WhatCount input operator, unique counter, and console output operator, they are all in the Malha library that I mentioned before, the operator library we built upon our engine. And they are different classes. And there are like more than, there are a couple hundred different operators there. So when you start with Apex, start to use Apex to write the application, probably sometimes you won't be able to quickly find out which operator does what you need. Right? It's kind of difficult to find a particular operator you want from 100 of different operators. So that's why we think we need to upon our existing library, we need to build another high-level API. Which make the existing library easy to use. So that's why we need a high-level API. So it should be, the high-level API should should make the beginners to easier to start with Apex application. And also we like the idea of the more and more popular Fluent interface. For example, if you look at the new stream interface that introduced in Java 8, it will do some message chain, and it will look the readability is very good. And also, we want to provide some similar API like Flink and Spark streaming, which is already very popular in this field. We want to cut the learning curve from other users. And also, like I said, for now, it's difficult to find the operators. So we want to put some very useful transform method into one single interface that user can easily find out, versus just do it in separate operators, right? So if you compare the high-level API of the existing operator API, the operator API gives you the flexibility and full power of the engine, and while the high-level API will give you a ease of use. So there are two. Sorry, I think the image messed up. The interface should be in that box. Anyways, so there are two interfaces here. One is called Apex Stream, and the other is called WindowsStream. Before I talk about this, I would talk a little bit more about why we have these two different interfaces. So when we when we take a look of all the streaming application that's out there, so all the streaming application fall into same pattern. Like first of all, you take some input, and then you do some transformations in the system, and then you do output. Right? Let's put input and output aside. Let's talk about the middle part, the transformation. So usually the transformation can be divided into two different categories. One is what we call stateless transformation, and the other is stateful transformation or Windows transformation. For stateless transformation, there are some, for example, map filter or flat map, which means each individual output only depends on each individual input, right? So you need for the operator to do those compute logic, you don't need to keep any state in that operator. So here comes the Apex stream, which does only the stateless transformation. And then the other category is called Windows transformation or stateful transformation. For example, group, reduce, fold, join, count. For those transformation, usually you should ask the window first, like which window you need to do this transformation, which window this transformation depends on, right? So there's a boundary, there's always a boundary for those transformation, and also to calculate these to do this transformation, you also need to keep some state, right? For example, if you do count, you need to keep the partial count to make the operator fault tolerant, right? You need always remember something in your system, keep something in memory in your system. So that's why we define another interface called WindowsStream, and in the simple Apex stream, it has three different type of methods. One method is the transformation. One type is transformation method, like map, filter, flat map, and the other one is the method that's used for interoperate with the old API. Like you can add add operator from Malhar library directly into this stream, and also you can set the properties for the operator. You can set the attribute for the application, the Apex application, so on and so forth. And the last type is the window method, which it takes a window definition and turn the Apex stream into a window stream. So because it means nothing to do those Windows transformation on without defining a window. So we figure out this is a better way, that you always define a window first here to turn the plain stream into a window stream. Then you are allowed to do the Windows transformation, like group, reduce, and join, something like that. Also, all the transformations there, it will return a new, the same type of stream. So the transformation here in the Windows stream will return another Windows stream, which carry on the Windows semantic defined previously. So this is useful because sometimes you want to do you want to group a chain of different transformations using the same Windows semantic. So in this case, the return value of those transformation, you can do another transformation on that, and the Windows semantic will be carried on until you call another window method here. Then you define a new window for the future transformation there. So here's a WhatCount example of using the high-level API, the streaming API, the Stream API. As you can see, this application compared to the old one is very clear what it does. It has some top-level method, like I put it in fold here, like import here, like from folder, flat map, then from folder read data from that particular folder, and then it line by line, and then it splits the line into words, and then it defines a window, like what window we want to do for those input, and then we do a count by key for the window definition, right? And then print the result to standard output. So yeah, as you can see with the new API, it's very clear. It's very clear that what this application does, and also it's less error prone because you don't add components like operators, connectors separately. So they are just like you build the things brick by brick in sequence. Okay, so I want to talk a little about the default implementation we have for the Apex Stream interface and WindowsStream interface and how it works. So literally, Apex Stream of type T means a bounded or unbounded dataset of type T. But in the implementation, actually, the Apex Stream of type T also holds a graph data structure, which include all the operators and connections between operators from the source to the current point. And if you call the transform method, like map, for example, map, flat map, group by, something like that, it actually add one or several operators, which delivers the transform to the current graph data structure, and then return you a new Apex stream of the type of the output. But one thing you should notice that the graph data structure in this implementation is not same as DAG in Apex. It's the graph data structure. It just keeps the order. How you add those transforms. It won't be translated to Apex DAG until you put all the transforms you want together and call the populate DAG method or run the run method. The reason is because sometimes after you construct your application, the engine would probably figure out some better way, like do some optimizations. So the real DAG might do transformations in different order to achieve a better execution plan. You can think it as a execution plan. And this picture shows you how we do it in the default implementation. As you can see, let's say this from several after several transformation, I have this stream of type T sub n. It also, as I said before, it also contains a sub DAG there. And then let's say, for example, we do a map on this stream of type T and T sub n. And the map is just transform the type T of T sub n to type T sub n plus 1. So what it actually does in the implementation is it has a wrapper operator there, and it connects to the operator exposed in the previous point, and by this way it just extends the DAG like bit by bit. Okay, so the current status of the high-level API. This is a this is the status of what we have done in the first cut. In the first cut, we already make the message chain available for just readability purpose, and then we already support the some stateless transforms like map, flap, map, filter. Also, the current API is already able to do I/O with file system, HDFS, console, and Kafka. And also the interoperability with old system is already there. You can add operator, get DAG, and set attributes, properties, so on and so forth. And also you can run the DAG. You run the DAG with streaming API in either local mode or distributed mode. And also the anonymous function is supported. So you can write something like the lambda expression in Java 8. And also, we make the current API extensible. Because in the real case, we always notice that the stream developer are usually different people from those developers who actually write the application. So we make the stream API extensible, so the stream developer can add more transforms as the first level method into the interface, and the application developer, whoever uses this customized stream API, can easily use it. And here's the current status for the Windows transform we have done right now. So the WindowsStream interface and a default implementation is already in a pull request, along with the operators that delivers the Windows semantic. So we have already done with a few window transforms like count, reduce. We support 2 different window types: fixed window, sliding window, and session window. We support 3 different trigger types: early trigger, late trigger, and at watermark for events that arrives before watermark, after watermark, and on watermark. Any trigger event you want to do on the watermark. And also we support 3 different accumulation modes: accumulate and discard, and accumulation and retraction. They are all mentioned in the Beam programming model, so it's fully it fully follows the Beam programming model. But all the Windows support we have done right now is we keep everything in memory, so you can only use it for a small amount of data right now. But next slide. In the roadmap, as you can see, the highest priority is persist the Windows state. For the large window state, we need to persist it into the persistent layer, so we can use use those window transformation with big data set. And because we already done some work in the in existing, we have some aggregation operators. We already done some work to persist the large state, so it's almost there. And we will, in the future, we will fully follow the Beam model, and we will give a rich selection of different kind of Windows transform, like group, combine, join. And also we will support more window mechanism and triggers. We will support custom window assigner and a trigger, just like Beam. And also we will make more I/O available. For example, HBase, Cassandra, JDBC. And also, we will have some schemas support. We will have some like table, like SQL, like API to make the schema that can be recognized by the engine itself. And also, we want to provide more language support because. Like if you look at the high-level API we have right now, it's already looks like it has some functional flavor inside. So I think the Java 8 Scala would be a very good candidate for writing a streaming application. And also we welcome everyone in a community to ask for features if they like. Okay. I'm done with my presentation. Any questions so far? Yes.
Yeah, the windowing support, will it be comparable to what you find in Beam?
Will be comparable to what? Sorry.
To what you find in Apache Beam.
Right now, we only have some basic Windows support. Not like as flexible as Beam, but we have it in roadmap that it will fully follow the Beam model. Yeah.
I was curious. You said that so if Apex has session windows, do you implement them? Like, how do you implement them? I guess is my question. I'm mostly curious. Is it kind of the same as how Beam does it, or do you have a different approach to session windows?
I'm not the person who implements those things, but the session window we have here is basically, for example, you can define the data that within some time gaps, and we have for supporting session window, we need to especially for late arrival tuples. Sometimes we need to do merging because some incoming tuple might change the session coverage for the window. Yeah. So I don't know if that.
Yeah, no, that's about the same approach.
Mm-hmm.
Yeah.
So, any questions? Okay.
So how are you going to manage the state for the windows? I assume there can be larger state accumulating depending on the window size and the key cardinality. What's the plan for managing the state in the operator?
We already done some work here. We already done some work for. We have some aggregation operator already in Malha, and in that operator we store it as a key value pair data structure in HDFS in a very. We use time and the custom key to store it in a key value pair fashion in HDFS. But it's now highly bundled into that operator. We might reuse that one and abstract out some interface that you can easily use other data store to store that kind of data structure. Yeah. Any questions? Okay. I guess that's it. Thank you.